Hey everybody, my name is Benjamin Ostrower, and my project for EduTech CS6460 is on detecting AI written essays. So to start off, the motivation, why is this an issue? Why do we need to solve it? Well, to start, with the advent of AI generative tools like ChatGPT and the like, students can write essays pretty much automatically. And this would constitute as plagiarism because they're not writing it themselves. And so it kind of presents a problem for institutions because how do they actually gauge how much a student is learning? Um, this has already started to happen. The Daily Mail reported that a student in Australia was one of the first to get caught cheating on their university exam using ChatGPT. There's a very good essay by The Atlantic that kind of details some of the dangers for higher education. Number one, it waters down the value of a humanities degree, as we know that writing essays and analyses is a very large portion of those humanities degrees. And if professors and institutions have no way of knowing who actually wrote the essay, students can just kind of waltz through their entire degree, just never having to actually write an essay, which is kind of the main point of their degree. So it really waters down the value of that degree, and in turn kind of hurts the university because it lowers the quality of their graduates. Another issue that could negatively impact the college institution is that it prevents take-home examinations. The professors would have to institute a pencil and paper format, and while not seemingly huge, but it can kind of waste resources in that you now have to basically commit the resources to putting those essays into a classroom format. It kind of prevents longer term, more thoughtful essays to be written because they all have to be done in class. So it just kind of wastes a lot of resources if these professors and institutions have no way of knowing how to detect whether an essay was written by a student or a machine. So this topic has been around a while. It started well before generative AI, but it's really picked up steam. The prior work has really centered around several different approaches. There's no one outstanding approach. The most recently hot, so to say, method is to analyze the text on a token level. And two seminal papers created these two projects called GLTR and Detect GPT. And how they work is by measuring the entropy and statistical likelihood of token choices. And to give you an example, if I basically gave you the sentence and told you to fill in the blank of the sky is blank, the most likely word most people would use is blue. So that's kind of the idea here, in that these methods sort of piece through the text and sort of mask the words and say, okay, the sky is blank, give me the top 10 words that an LLM would have used, and then go back and compare to the actual word. And is that actual word in that top 10 list? And they just kind of run statistical tests on how likely having a certain amount of high likelihood words are in an essay. The next measure is coherence measures. Zhang in his paper Neural Deepfake Detection of Text creates basically a two-pronged approach to detecting fake news. His architecture combines factual coherence and next sentence prediction. And what these terms mean is effectively the next sentence prediction basically works on feeding a transformer network or some sort of decoder text generative network the first sentence, and then basically having it create the next sentence, and then comparing that to the actual sentence and computing similarity measures to see just how near the generative sentence is to the actual sentence. Very similar to the token analysis, but just sort of on a sentence level. And then the factual coherence was actually pretty interesting. How he did it was he used something called named entity recognition, which parses out basically the pronouns of a text. And he will then embed those pronouns into a embedding module called Wikipedia 2vec, which basically embeds those pronouns into their Wikipedia relations so that you can kind of have like sort of a semantic similarity measure. So to provide an example, if an essay was talking about Mars and Jupiter and Saturn and the like, you could kind of lump those pronouns into astronomy type measures. Like if you were to visualize it on a 3D, those three pronouns would be kind of clustered together in sort of words similar to astronomy. Whereas then, if the paper goes on to start talking about McDonald's and Burger King, those aren't really related to astronomy. Those are more related to fast food and restaurants and such. And so their space in this imaginative 3D space would be a good bit of distance from the original astronomy pronouns. And so that factual coherence is kind of like a proxy for, exactly as it says, factual coherence. The next approach is using abstractive summaries. I can't pronounce the author's name, but in his paper, Neural Abstractive Text Summarization, he will pass abstractive summaries of news articles into a basic transformer network, like an LSTM network, to basically detect whether this text was written by an AI or not. And by abstractive summary, what that basically is that they read the news article, in his case, and create a summary using completely new words. So an extractive summary would just kind of trim out the unnecessary parts of that article, whereas an abstractive summary uses new words not found in the article to create the summary. And then finally, automated essay scoring. This isn't necessarily related to detecting AI written text, but it's very tangential in the fact that it's related to essays, and it can be reconfigured to do such. And a good paper on this is by the author Ludwig in his essay, Automated Essay Scoring Using Transformer Models. And he basically takes a very simple approach of just embedding the entire essay using a BERT model, a bidirectional encoder representation using transformers, and then just passes that through another transformer to basically create a score for an essay. Very simple. So my plan is to actually combine all of these four methods into a singular unifying approach. All these approaches kind of took a singular avenue, but my plan is to craft a neural network to encompass all of these into one network, and then output this into a binary classification model. So effectively, how we would measure the performance of this is just your typical classification metrics, your F1 score, your accuracy, your precision, your recall, because we'll be able to take in all the information that we get from those four approaches, sort of distill them into this network, and then it'll output a probability, which we can then use to classify whether an essay was written by a person or a machine. And then obviously we kind of need a baseline method to see whether these actually improve. So some typical baseline methods that you see for like automated essay scoring and the like, or authorship attribution, is like a long short-term network with a convolutional neural network, or just a straight BERT. So to date, most of my work thus far has been on data collection. I scraped 20,000 essays from EduBirdie, but due to the computational constraints of running those methods previously described, I had to whittle that down to about 1,300, which basically amounts to cutting down all the essays that were 500 words or less. Just only look at those essays. Then, once I had those 1,300 essays or so, I then used a large language model called Falcon, the 7 billion parameter version, Falcon 7B Instruct, to create the AI written essays. And I did this by using LangChain to sort of create like a prompt version. And the prompt that I used was, pretend you are a student, please write a blank word essay on blank, feeding in the word length and the title. And then that would then spit out an AI written essay back to me. And then finally, I've also calculated the number of top 10 samples for words written by both human and AI written text. This goes back to the very first prior work, the Detect GPG and GLTR. By top 10 samples, what I basically mean is that I start on the 30th word of every essay just so that I can have some context. And then I have it predict the next word, but give me the top 10 choices that the LLM would use to fill in for that next word. And then I compare that to the actual word, and if that actual word is in one of those top 10 word choices, then I basically increment and count how many times in an essay that we see those words. And due to constraints, I couldn't do every word starting from the 30th word on. I had to basically start at the 30th and then do every 5 words, so that this sort of window would grow by 5 words every time to capture the context. So some interesting finds on the engineering front. The inference for the text generation models, even on the smaller 7 billion models, some of these large language models can have tens of billions of parameters. Very, very, very slow. I had to sign up for Google Colab Pro, and as you can see, I mean, I was a little overzealous with my 20,000 essays, but I had to really cut that down just because they're so slow on the text generation front. Inference for the masked input, which is basically how I get the token level analysis, is relatively lighter. I didn't have to run that on a GPU. You could run that on base Google Colab version. But obviously, due to time constraints, I couldn't do every word. I had to just do every 5th word. And since I was able to calculate the number of top 10 tokens in an essay for a human and an AI, in the graph to the right, you can kind of see the box plots for human and AI for how many top 10 token counts you see. It's very, very similar. Just using straight summary statistics isn't quite enough. So going forward, we'll have to kind of see how substantive that metric is. But for now, we're going to keep it. So finally, the next steps for intermediate milestone 2. I need to create abstractive summarizations for both human-written and AI-written essays using the Hugging Face and LangChain modules. Hugging Face also provides a next sentence prediction package that we can use to kind of use for that coherence measuring. And then finally, I need to create dimensional reduction embeddings using BERT, which is similar to that transformer paper for automated essay scoring, and this is how they feed in the entire essay into a model to score the essay. But in our case, we're going to detect whether it's written by human or AI text. And that's